Can you hear me with this? So you have to maintain silence, okay? In between, I will just where did we stop? The last two B, right? So B part में क्या है? Consonants and natural. Okay, natural dance. Okay. So let's differentiate. Okay, silence, everybody. Can I have your attention?
Yes, sir.
Okay. So, what is natural frequency? I'm sure you all are aware of natural frequency. That natural frequency is natural vibration, right? So, what is natural frequency?
Natural vibration.
The number of vibration. What is actually
Cause of natural.
From the number of vibration of the body in the absence of external factors.
So he says number of vibration of a body in the absence of external factors.
Natural sequence.
So you're quite right, okay, but I want meaning. What does it mean? Did I share in the last class any body which is capable of vibrating? Okay, when it is set into vibration, it will be in its natural level. Because every body has a unique frequency, which is called its. That is why we call it as its natural frequency, right? But then in real life, that's not possible. Okay, because no body will be able to vibrate at its natural frequency. It will eventually die, right? Due to the presence of atmosphere or surrounding air. Okay, got it? So, but then still we will define it. When a body,
But it may happen in the still air.
it is only possible in vacuum. Nowhere else.
So, but in vacuum sound you cannot travel.
No, but it is vibrate. We are talking about vibration, but you will not hear any sound. This is not about sound. This is about something else, vibration, about vibrating body, right? So, when bodies that are capable of vibrating are set into vibration. It vibrates with its natural frequency. Is it natural frequency or
Naturally vibrating.
natural value? Okay. So this is also called as free vibration. Understood? Ideally, this should happen, right? But in reality, it is not possible. Right? In reality, it is not possible due to presence of
Sir, if in reality it is not possible, then why do people actually vibration?
so don't we set very high aim for ourselves? Like I'll achieve 100%. Right, high for it. And then I reach very close to it, and sometimes I get 100%. But then getting 100% doesn't mean that I know 100% of the subject. So it's just like in your mind, like I know 100%. You know what I mean? So it's ideal thing. So we defined an ideal benchmark for us. So in science or in everything, every field, we do this. Like in gases also, you have ideal gas now. Why do you have ideal gas now? Real gases never reach ideal gas. So ideal situation is subject to certain assumptions. This is an assumption. Okay, so we'll try to achieve this. Because in reality, to work, we need this kind of vibration, which are sustained. But that will be achieved when we do some work or spend some energy. We'll see that. This is ideal thing. Okay, the reference for us. In reality, it is not possible due to presence of dissipating environment. Such as surrounding area. Okay, so see this. I set it in vibrating. Don't miss the point. Is it stopping? Is the amplitude reducing?
Yes,
The amplitude is reducing because it is constantly. Air is opposing its water constantly. So what happened to the air which was in contact with it?
This is very
Huh? So what happened to the air? The air became hot. So this mechanical energy got lost in heating the air. So that energy is lost. Lost from it, but not from the nature. It is given back to nature, but now it is in degraded form. That energy is no more available to vibrate the metal. Is it understood? Okay?
Yes, sir.
So if it was in vacuum, assumption, then it will keep moving and who defined it? We defined it, right?
Yeah.
Who defined natural vibrations?
Sir, that guy.
Without any external force, somebody was saying.
Yes, sir. I said without external force.
He also said the same thing. So you were all correct, right? But that is not possible in reality because of existence of air. If natural vibrations were possible, how would it look like?
Sir, we can take the natural vibration as an example of what. Yes, sir, we can see.
How would it look like?
We can hear the vibrations of the some earthquake or
With time, vibrations of
earthquake or some tectonic plates when it is moving, we can able to hear that.
See, you don't relate it with sound right now. We are discussing natural vibration in general. It could be anything. See, every vibrating object you will not be able to hear unless it is more than 20 hertz. Are you with me? This is not vibrating for like, if it is less than 20 hertz, I will not hear. Can I hear this? It is in air, it is vibrating, but I can't hear it. So vibration has to be more than 20 hertz. Okay, for us to be able to hear it. Okay, समझ आया? So not every vibration is audible by human. Right. So, so how should a natural vibration look like? It should look like this. The amplitude should remain constant. Amplitude signifies energy. Okay, so energy is not reducing with time. That is how a natural vibration should look. Surrounding. Yeah, that is my problem. So you just surrounding it. When I speak, okay, that's why you need to listen to me carefully. I don't make mistake while I'm speaking, but writing, spelling, I make many bookouts. Okay, so that's why you have to pay attention to what I'm saying. So everybody understood what is natural vibration? What is this x-axis? What is this y-axis? Displacement from mean position is, so I can call it x, y, whatever. Okay. And what is this maximum displacement? Plus A. This minus A, right? Plus A minus A, amplitude. Okay. Time. Frequency is how many cycles in 1 second? Okay, how many cycles in 1 second? That is good. How would a damped vibration look like now? Now that you know natural is like this. In damped, what happens? So the vibrations eventually died. So how will it eventually die? Slowly. So how should it look like? Should it not look like this?
Amplitude will decrease as it.
Right, see the diagram in the book. This may not be very. So its amplitude will decrease gradually with time.
So it is due to some force that is stopping.
Dissipate. Energy is. So some work is done against the air. Every time you are working against, when you work, a body that which does work loses energy. A body which does work loses energy. A body on which work is done gains energy. I did work on this. So it has now energy. Now this is working against the air. It will lose energy and therefore the amplitude reduces. Got it? Got it? So that is all. So the damped vibration looks like this. In reality, natural vibrations do not exist. As silence. Silence everybody. Silence everyone. I'll send some. I'll send some of you outside today. I'm seeing you as well as him. Both of you will go outside. Okay. Maintain silence. Your responsibility. Reality, in reality, do not exist as the vibrating body loses energy. Who is Arshita?
You're talking too much. They're talking without saying.
I just met your.
Yes, sir.
So you better behave. Next time I'll speak to your mom and I'll tell what you do in the class.
What are you, sir? They're complete.
As the vibrating body loses energy brings what? Gains. Right? In reality, natural vibrations do not exist as the vibrating body loses energy in going work against the surrounding air during the oscillations. Is it understood? I think I explained and now, and that is why it is not natural but damped. Okay, so this is the real vibrating body looks like. So this is the waveform. Now what is forced vibration? Let me give opportunity to somebody else. Do what?
To bring vibration in the body.
And then the body vibrates with what frequency?
Irregular frequency.
So, okay. Now look here. Everybody. Is this a force vibration?
Yes.
How many say yes? This is not a force vibration. Was that a force vibration?
Yes.
When bodies that are capable of vibrating are set into vibration, once I will set into vibration. Okay, it vibrates with its natural frequency. It is natural frequency, but it is a damped vibration.
Yes.
Was it a force vibration? No.
No damn.
So in the previous two examples, when I did, you said it was a damped. How then now it became a force vibration?
What is
What was different when I just set it in vibration this time than the previous two times? Same thing, na? So कैसे force हो गया? देखो force क्या है? Listen, this is force. माँ बच्चे को झूला झूला रही है. This is when on the cradle, it's a periodic force. Yes, that's the difference. Got it? So here देखो. Here, when it lost energy, listen, when it lost energy, during each oscillation, it is losing energy. I supply that energy back. Okay, that is periodic force. So, in force vibration, what is the frequency of the vibration? Frequency of the vibration is the frequency with which the force is applied. Understood? And the frequency is equal to the frequency of the periodic force. How many times in second we applied the force? That is the frequency. So in a forced vibration, the body vibrates with the frequency of the periodic force. Okay? Got it? Got the difference? What is forced vibration? So in forced vibration, why do we need force vibration?
बच्चा सोएगा नहीं तो अपने पूछ
Okay, why are we learning all this? जो automobile है, how the automobile runs? There is an engine. Engine में क्या होता है?
उसके बाद हाथ से
अभी ऑर्डर किससे नहीं सर? सिलेंडर है ना? हमारी गाड़ी में इंजन होता है, इंजन में क्या होता है? सिलेंडर और पिस्टन। इट इज बेसिकली अ थर्मोडायनेमिक सिस्टम। ठीक है, तो हर इंजन में क्या होता है? ये होता है। अरे ये this is only a concept. I don't draw this. This is for understanding course. क्यों चाहिए? क्या होता है? When you start the vehicle, okay, when you give the crank, you turn the ignition. Ignition में क्या होता है? You inject fuel, और spark is produced, so there is a combustion. ठीक है, जैसे कर जो स्टार्ट हो जाती है गाड़ी, तो क्या हो जाता है? जो आवाज कैसे आती है? वो पिस्टन क्या करना शुरू करता है? Starts vibrating like this. कैसे होता है? देखो, this is a wheel, right? ये जो wheel है, this is called flywheel. So every engine has a flywheel. Okay. So when the engine is started, this combustion takes place, due to which the gas expands. So when the gas expands, what will happen? This piston will go up, therefore this wheel will rotate. है ना? There is a rotation mechanism. This wheel rotates, and therefore it will have inertia. So due to expansion, it rotates, and due to inertia, it will get compressed. But again, the gas is expanding. So there is a continuous expansion compression. And this vibrational motion is resulting into a rotational motion. Okay, so we achieved a rotational motion of the wheel. So that means this rod is now rotating like this. So when you start the engine, it starts turning. Then there is gear system. Motorbike. So then there is a gear system. Then you put it in gear, then this rotating shaft will start moving the wheels. Only with gears. So you have different combination of gears, right? Small gear, big gear, like that. So this vibratory motion is converted into rotational motion, which will then pull the automobile. So in real life application, we need this kind of vibration, continuous. This is vibrating up and down, but it is translating into motion. Okay. So all the mobiles they are using. So every machine, whether it is a sewing machine, what do you have? The needle goes up and down. Then you have the mechanical. So this is a very important question. Yes, sir. So the most vibrating around. Very, very important. Who is causing that vibration? What was the cause of that? Huh? बोलो यार, मैं किसके लिए चिल्ला रहा हूँ? ये नहीं पता. So what did we learn here? That force vibration अगर नहीं होता, How are we attaining this kind of vibration now? Are we attaining this kind of vibration? No. We have to, right? Here we are attaining this kind of vibration. No? But how are we attaining constant amplitude? By burning fuel, by consuming energy. समझा ना? क्योंकि अगर ये fuel अगर burn नहीं करेंगे तो एक बार घूमने बंद हो जाएगा. Constant. So we are constantly burning fuel, right? That is what is force vibration. So because in reality, if you want to do any useful work, we require sustained vibration. That sustenance is due to force vibration. तो फोर्स करने के लिए हमारे पास कोई एजेंसी चाहिए, या तो मम्मी धक्का देगी, ठीक है, या फिर तेल जलाना पड़ेगा, ठीक है, या इलेक्ट्रिसिटी से केमिकल टू इलेक्ट्रिसिटी टू मोशन, कुछ ना कुछ एजेंसी चाहिए जो वो काम करेगा, फोर्स वाइब्रेशन. Got it? Yes, sir. So continuously burn or spend energy to achieve this. Understood? Got the perspective?
Yes, sir.
Okay. तो चलो ये मैं मिटा देता हूँ अभी.
उससे एक स्लाइड में कितना मिलता है?
एक सबका अलग अलग, सबका अलग. वो सीसी रहता है ना, सबका वॉल्यूम 150 सीसी ऐसे, वो सब वही. तो जिसका जितना ज्यादा सीसी है उसका उतना कैपेसिटी. सब और कॉम्बिनेशन 10वीं में नहीं, वो थोड़ा मैकेनिकल इंजीनियरिंग. So in this case, sustained oscillation. Periodic sheet. One second. This is sustained oscillations are obtained by supply. Over. Okay. In this case, yeah, who was asking? Who was asking some question here? In this case, sustained oscillations are obtained. Oscillation मतलब vibration हो गया, ठीक है? Obtained by applying external periodic force to overcome the lost energy during each oscillation.
Sir, can you draw the diagram of piston again?
No, because that is not required. It was only for your understanding, it's not required. Matlab, if you are, I mean, you are not even ashamed of asking this question, right? Huh? And not being quiet and.
It's applying external.
Thrust में नहीं है, वो अलग है यार. That's different. That's about floating bodies. Up thrust you.
No, sir, thrust.
कौन से thrust?
These are the force. One area is equal.
It is pressure. Pressure.
Yes, sir.
कौन से तुम्हारे बुक में है क्या? नहीं बोले था ना, तो that is floating body. अरे अब thrust मतलब thrust जो नीचे से ऊपर लगता है, thrust मतलब जो ऊपर से नीचे, same thing. Thrust means normal force. The direction could be top down or down. A thrust is by water or any fluid. Damped vibrations are the real vibration. Like this was damped vibration. Eventually it will stop. Stop over here. Is it vibrating after some time? Yes, it will, let's say 10 times it will oscillate and then it will stop. But force vibration, we are forcing it to continue the vibration till we are forcing. So it is sustained. Yes, if I continuously, so I am spending energy, no? So I'll get tired after some time. That means my energy is used in vibrating. So you will need some energy or some agency to cause force vibration. अरे वो बाद में बात करेंगे मम्मी से पूछ लेना क्या वो in this case sustained oscillations are next during force vibration. During force vibration. The body so during force vibration, what happens? The body vibrates with periodically. Periodic force. Force लगा है 1 second. That is it. Yes. Sir, तो hertz का unit है volt per second होता है and newton per second. Hertz का unit नहीं hertz. नहीं hertz नहीं sorry. Frequency का क्या unit क्या? Newton per cycles per second. It is just per second. Per second. How many cycles? So how many times it goes? That is the periodic force. Okay. So now, what is resonance?
Sir, it is a phenomena where the force applied to that object is equal to the natural vibration of the object.
Yes. So right now I said, now every body. अरे भैया खड़े हो या तेरा फोन में साफ कर दूंगा लेके आ सर नोटबुक लेके फर्स्ट शिफ्ट है भाई नेक्स्ट प्रमोशन विल बी आउटसाइड द क्लास तेरा सिर कभी आगे रहता ही नहीं फोर्स वाइब्रेशन करना पड़ेगा तेरे समझ में आ रहा है इधर ही रहनी चाहिए थी हाँ भाई साहब आ जाओ आप भी आ जाओ आइए इधर आइए हाँ हाँ ये बैग हटाना जरा आ जाओ फटाफट so nature itself has decided that natural vibrations are not possible. Force is needed if you want consistent work to be achieved, right? So time पे force लगता रहेगा. ठीक है? So during force vibrations, the body vibrates with the frequency of periodic force applied on it. Now we want to discuss an important phenomenon called resonance. Resonance. ये तीनों सबको समझ आ गया?
Yes, sir.
Can I erase the left two side?
Sir, you can even the force vibration.
So we are going to discuss now resonance. What is resonance? So resonance is a special case of force vibration, where the frequency of the force applied is equal to the natural frequency of the vibrating body. Whenever that happens, the oscillations take place with maximum amplitude. That is resonance. Okay. So what is resonance? During forced vibrations. Okay. It's a special case. It is a special case of silence, please. It is a special case of force vibrations. Special case of force vibration, where the frequency of applied external force, external periodic force, matches the natural frequency, of the vibrating object. Have I written what I have spoken?
Yes, sir.
Yes. Okay. So at resonance, the body vibrates with maximum amplitude. So amplitude of the vibration signifies its energy, right? So during sound waves, okay, if the resonance is taking place, then you will hear a loud sound. Like when two of you start speaking at the same frequency, then the sound will be multiplied. Okay? Have you experienced chorus?
Yes,
Yes, sir.
So everybody is singing at natural strength, but suddenly the chorus sound looks very big. Yes, sir. That's what it is. So that is resonance. Now resonance is not only in sound waves; it happens in various phenomena, right? Like in case of electricity, when you're tuning some station, right? FM channel.
98.
You go to so between three channels, the signal is not very clear.
Yes, sir.
So that means there is no resonance. At resonance, the signal will be heard very clearly. Understand? So resonance has many applications. Okay. So you will learn about it. But is the concept clear now? What is resonance? Yes, sir. What kind of vibration is it?
Force vibration.
Force. A special case of force vibration. All right. So with this, I think we are done with the second part of the sound chapter, because there are many other things which are not in the syllabus. Not in the syllabus for Test.
Nice.
Huh?
Subjective and objective.
During residence, the amplitude is the maximum. Highest one is the amplitude. So in your book, there are some examples of resonance. There are, you're not writing now. So in your book, there are some examples of resonance. So now read the examples of resonance. Article 7.10. 10.10. Okay, so there are some 7. So many examples are given. 5, 6 examples are given. You read that. You sit there. Everybody read some examples of resonance. And then if you have any questions, you ask.
The resonance is constant. Constant or it does it get started?
What do you mean? What will tongue, सबको पता है क्या tongue? When the air is blown into it, right? When our frequency matches the conch frequency, then loud sound is produced. That is an example of resonance. So when you blow air, at every air you don't hear the loud sound. Okay? So resonance means when the resonance is created, you hear one sound, and if you increase your amplitude, that amplitude also amplifies. Okay? So I'm trying to give you all the possible examples. Conch sound everybody has heard, right? Conch, tongue. Conch ही बोलते हैं ना उसको क्या बोलते हैं? tongue देखा होगा ना सबने सुना होगा. Any more questions? Read the examples, then you'll have more questions.
सर एक से मुझे पता है कि म्यूजिकल इंस्ट्रूमेंट जो मुझ से बजाते हैं
Mouth organ.
अच्छा माउथ का एग्जांपल है
देखो साउंड का ना मतलब कोई भी जो म्यूजिकल इंस्ट्रूमेंट है उसका एक फंडामेंटल फ्रीक्वेंसी होता है जो सबसे स्मॉलेस्ट साउंड है उसका सबसे स्मॉलेस्ट फ्रीक्वेंसी ओके दैट इज कॉल्ड फंडामेंटल फ्रीक्वेंसी दैट म्यूजिकल इंस्ट्रूमेंट यू कैन प्ले ऑल द मल्टीपल्स ऑफ दैट फ्रीक्वेंसी दे आर कॉल्ड सब्सिडरी नोट्स सो जिस म्यूजिकल इंस्ट्रूमेंट में ज्यादा से ज्यादा सब्सिडरी नोट्स होगा इट विल बी I mean, you can play that with more variety, different sounds. Each sound is multiple of the initial frequency only. You understand?
Yes, sir.
So it depends on the manufacturing quality of the instrument. इसमें कितना richness है in terms of music scale पे. समझ आई बात?
Yes, sir.
More than that is not required at this stage. Read the examples, 7 examples of resonance, and then you ask me questions. All of you, all online students, read the examples of resonance in your textbook.
Okay, sir.
This one. Some examples of resonance.
Yes. Sir.
Yes, somebody was asking me. You have not used washroom in this year? Help yourself. Outside, I think. On your left. May I use the washroom? Yeah, acha, okay. I thought I thought he's saying where is it? Getting old.
Sir, every most of the
Acha, how was it? Good? Okay. Nice. Keep it up. Okay, so how many of you attended PTM? I can recognize her. Anybody else who attended? She was present.
Sir, next week,
Who was there?
next week Saturday.
Next week Saturday. I mean, less number of you come, it's okay for us.
I'll be 5:20 days. I just have to log in and sign something.
So I think all of you are quite bright, okay? It's just that we have to reach the residence. Huh? You understand? What is the meaning of resonance? All of you have your own natural frequency. I am applying periodic force on it. And then we have to match it. So who matches those frequencies? You match mine or I match yours? We don't.
Sir, actually, it's both.
Huh?
So both will mix together.
Both will be. So it's not a resonance case, right? Because we don't know, like if your natural frequency is good enough. Right? So if the natural frequency is not good enough, then I don't know, that's not a right example.
Sir, the background thing is try to match in our frequency.
Orchestra.
So,
So the harmony, right? See right now, what is going on right now is the sound is killing each other. There's a chaos, right? Noise. That's what noise. But imagine a situation where everybody started reading a line together. It will be magic. Ah.
Sir, डाल ना करना उधर है सर. सर आप कैमरा में देख लो सर.
So there is a question on fifth example. So there is a question, right? Fifth example, is it resonance in a bridge?
yes, sir. Yes, sir.
Has anyone understood resonance in a bridge? There are many of you who have not read it, right? Fifth example number 5.
When I do process, it's soldier are asked to break their steps. And the reason is that when the soldiers march in the steps, we soldier and some same place and the force that is and vision of
Right, you read it for yourself. So let us say. So this is a bridge, okay? Suspension bridge.
हाँ सर अच्छा नहीं करते.
Now, soldiers are marching on it. So soldiers कैसे march करते हैं?
सर अच्छा
March past. You see march past.
yes.
Let's have one conversation. Can we all have one conversation? Ask him to look here. Everybody look at what? Why are you? Kaise? Can you wait till the end of the class? Pay attention here. Now listen, what happens? Hello, bridge. Look here. Bridge has got its own natural frequency, right? Now when soldiers are walking over it, and if their walking frequency matches the bridge's frequency, then it will start oscillating with maximum amplitude. So anyway, a suspension bridge would oscillate. But if it achieves resonance, then it may oscillate and break itself. Right? That's why the soldiers are asked to discontinue their march past. So they are dispersed. Okay? They are not walking together now. They are walking randomly. They will be asked to break their patterns. Don't walk in the same line. As a talk karke chal raha hai, it anyway produces a very loud voice. Yes. Voice. क्या बोलते हैं? Frequency. Noise. Sound. Noise बोलना ठीक नहीं है ना. Sound. So if that sound frequency matches the bridge's frequency, the bridge will start to oscillate. ठीक है? It will oscillate with maximum amplitude, and that may break it. Yes, sir. Okay. So that's why. Any other example? Have you all read the sixth example? Resonance in radio and TV.
जैसे रेडियो का to the space, so there is a satellite that able to send space vibration.
But TV it's not space, that's not towers. TV is not space.
है ना satellite communication. That's for local distribution. Cable TV. Right? Yeah. Local distribution is that, but from country to country, right? You need satellite. Okay. So with this, I think we are done with part B. Is there anything you want me to cover? These are only 4 things in this. Are you talking about seed? Characteristics of sound from seed. That is left. How much more time we have? How much more time we have? Only. Okay. In the next class, we'll start with characteristics of sound. Right? Characteristics of sound and objective and subjective nature. That we'll do in the next class. Anybody has any doubt in what we discussed today? Good on that. क्या बोल रहे हैं? There are so in the next chapter, you don't have all this logarithmic expression and all. It's not. Okay? It's only the qualitative definition of characteristics of sound. That is loudness, pitch, and quality. Only these 3 things. Log antilope is omitted. It's not there. Okay. So, anybody has any doubts? Online students, do you have any doubts?
No, sir.
Okay, so in the next class, we should be able to finish this chapter. Okay? All right.
Okay, sir. Bye, sir.
Any doubts? I can't hold them, no? What? हो गया क्या? चलो ठीक है।
अरे बुधारू कौन है तब मतलब रहने का मन है मेरा बस भाई मैं दबी मुंबई नहीं रह रहा भाई मैं जा रहा हूँ हाँ